Hello ladies and gents, welcome to another repair video. Today we're going to be working on this PlayStation 5 which I've got in front of me, and this PlayStation 5 has been sent in because it's got no power. So it's a little bit different to the PlayStation 5 repair videos that I've done so far. I've not come across one with no power until today, so this should be rather interesting. But we're going to take a look, we're going to see what we can do and hopefully get this thing fixed. But while I've got your attention, if you are new to the channel and you appreciate this type of content, I would really be grateful if you hit subscribe and turn on the bell notifications. That way you don't miss any future videos. And if you think I'm looking a little bit too skinny, then you can head over to Twitch, you can link your Amazon Prime account, and you can become a Twitch Prime subscriber. That is absolutely free if you use your Amazon Prime account, and it gives me around about $2.50 every month, so I can buy some food. So with that being said, let's get into this repair. These are just way too big for the camera setup. It's pretty annoying, but never mind. So while I'm doing this, I want to give a shout out to a couple of people. The first person that I want to give a shout out to is Wayne from Wayne's Noob Repairs UK. Wayne is a good friend of mine. He is a genuine guy, down to earth, and he's just starting his YouTube journey. We're doing a challenge at the minute. Obviously this isn't part of the challenge, this is the job that's came in. But we're doing a challenge at the minute and you don't want to miss it because it's going to be pretty fun. So if you aren't subscribed to his channel, I highly recommend checking him out. He is just starting to do repairs, but he's also documenting his journey on YouTube. Great guy, great personality, good laugh. Honestly, go check him out. I really recommend it. And the second person is going to be Kiki from Kiki's Hobby Repair. So Kiki is a top tier supporter of the channel. He's a great guy. He's been a supporter for a long time and he also creates repair videos. He does a lot of Nintendo Switches and things like that. But he's a genuinely great guy. I really have mad respect for him. He's a good technician. So I highly recommend checking him out as well. There'll be links to both those channels in the video description. But with that being said, let's just see what goes on with this. Okay, so it's absolutely dead. We've got no signs of life at all here. Let's just offer up a disc and just see if it takes in a disc. See if it powers on that way. No, it does not. So the disk drive isn't picking it up either. Oh no, that's an Xbox One disc, but that doesn't matter. But the disk drive is not picking it up either, and it's not turning it on. So it could be a number of things. The only real issue that I've found with these so far from videos that I've watched, because I do watch repair content myself, but the only issues that I've seen so far are pretty much just power supply issues. I'm hoping it's not that because I don't have any, so I would have to repair the power supply, or at least attempt to repair the power supply that's in here at the minute. So I'm hoping it's not the power supply. I'm kind of hoping it's the Southbridge. It's definitely a possibility that it could be the Southbridge. But the problem is, like I said, I don't have a power supply, so I haven't really got any way of fixing it if it is the power supply. That's the only problem. I do have another console in the queue which I can use to test the power supply. So if I'm not getting any output from the power supply that's in here at the minute, then I could potentially use the other power supply that's in the other console just to try it and see if it works. I have done that a few times. You know, if you get stuck, sometimes you can, you know, grab one out of another console that you might have in the queue. As long as it goes back, then, you know, there's no real harm in doing it. So let's just get it apart and we'll see what's going on, and hopefully we can get it fixed without having to buy expensive parts like power supplies. So I'm going to get this opened up. It's going to take me a while, so I'll get it apart and I'll resume the video when I'm done. Right then, okay. So I've got the motherboard out here. And one thing I'm curious of on this one is why hasn't this gone back under warranty? Because I'm pretty sure this would still be under warranty. Even if the customer has had prior work done to it, for example on the HDMI port, which to be fair, they haven't. It looks like a factory port. So even if the customer had prior repairs done to it, as long as that wasn't the cause of the no power issue that it's facing now, then Sony wouldn't be allowed to refuse a warranty. So it doesn't make much sense why this hasn't gone back under warranty. Unless it's just out of the warranty period, which, I mean, if that's happening just out of warranty period, that's pretty scary, to be honest. But what I want to do first is, number one, I want to test the power supply and just see what's going on with that. So if we flip it back around, we can see here that on these pins here where the power supply goes, we've got a big trace here. It goes across to here, it goes across to here, and then it goes from here onto the VRMs and things like that. So the VRMs are the voltage regulation management things. So basically we know that the 12 volt part is going to be on this pin here, and that this one here is going to be ground. So if we flip that round and then look at it in reverse, then in the orientation that it's on in there with the power button here, the left hand side is going to be 12 volt. So we know which side we need to probe with the multimeter in order to find out what's going on and whether the power supply is putting out 12 volts or not. Now it might be a case where it's putting out 12 volts, but then it just slowly drops. So we do need to monitor the voltage for at least a little while just to see if it puts out a constant 12 volts and it's stable. Yeah, so let's just plug this in and we're going to see if we get 12 volts. If we get 12 volts and it's stable, then chances are the power supply is good. And we do. We get 12 volts from the power supply. So what I'm going to do, before I go any further, I want to see if we're getting any voltage at the power button. So I'm going to pop this back inside the housing for a minute. So if we pop one probe on ground, the black probe, that's going to be the negative. We should get 12 volts here, and we do. We get 12 volts. So what do we get on this power button? So let's have a look on this resistor here, and we're getting 3.3 volts, which is normal. Interesting, we're only getting 2.8 on that button. Now I don't think that's normal. I keep slipping off the resistor though. Very fine. But we're only getting 2.8 volts there. I'm pretty sure we should be getting 3.3. So I'm just going to probe around a little bit, see if I can find anything out of the ordinary. So let's just see if we've got any voltage at all around here. Okay, we get 12 volts here. So on this chip here, we've got 12 volts. Alright, so around here we've got the Southbridge. So I believe the Southbridge is there. So what I'm going to do is I'm just going to look around this area here for any kind of voltages. See if I can pick anything up. We get 3.3 volts up here. 0 volts. Interestingly, the voltage on this coil here is dropping down to 0. That could be shorted. So when we get a short on a specific line, then what we're essentially doing when we're probing for voltage is we're touching the probes together because it's potentially shorted to ground. So it could be a low impedance line, it could be perfectly normal, but it is going to 0.0 millivolts, which would happen as well if I was touching both probes on ground. So that could be shorted. I'm just going to keep probing around, just see if I can find anything. Yes, I'm there, 0.0, just up here off camera. So this cap just here, 0.0 volts. This side, 0.0 volts. So that's telling me that that's showing up as short. I'm going to have to remove the power supply. So I'm going to have to get the board out. I've got a feeling this Southbridge is short. So essentially what I mean by that is this. So voltage, in voltage mode, you can still technically look for a short in voltage mode. And yes, I understand that if there's power cycling through the motherboard, that it would potentially show up as short on certain lines because the path is complete. I get that, I understand that, but let's say for example this cap here, so you can see what's happening here. We've got 0.0 volts or 0.0 millivolts, and then this side as well of the same cap we've got 0.0 millivolts as well. If I touch both probes on ground, we get 0.0. It's exactly the same as doing that with your leads. It will nullify your leads and it will come up with 0.0 millivolts. Let's just take a nose and see what's going on. So I do have a donor board with a good Southbridge on which I can use to confirm anything that I'm getting. Okay, that line is not short. I am getting a lot of shorts around here. Okay, that one's not showing up as short. Okay, let me just grab a donor board. I'm going to do some tests on a donor board and see what kind of readings I get then. Okay, so here's my donor board, which is covered in an incredible amount of flux. Let's just see if we get the same kind of reading on this one as we do on the board that we're working on. So I've got the meter in continuity mode still. Okay, we do not get continuity on that. Okay, no continuity on that coil. Okay, we have something different. So that coil which I just checked is just here. That's giving me 2 ohms and dropping on both sides of that coil. Donor board. No continuity. No beeps at all. We have something different on the Southbridge. And the PlayStation 5 Southbridge is CXD 90061GG. I do not have a stencil for it. I think that's been reflowed. That's probably why it hasn't gone back under warranty. I think that's been reflowed. Okay, so I'm going to have to get this Southbridge off. But I believe that's been reflowed. Look at the state of that. Yeah, so this is going to probably a repair attempt. Alright, so this is the chip I need to take off. And the way I'm going to do it is with hot air. Actually, I could take that off first. Let me just do a quick look. Let me just do a quick inspection here. Because this is going to be the first time that I've obviously replaced the Southbridge on this particular board. So, where was the coil? The coil was there. I don't think this little chip here is going to have anything to do with that, but it's probably going to be better to take that off before I end up taking the Southbridge off. So I'm just going to remove that chip and just see if we get any kind of different reading. So I've got my hot air set at 420 degrees Celsius at 40% airflow. Okay, so there's that chip removed. Kind of dropped it a little bit there, but never mind. Let's just see if we get a short on that coil now. Probably do. I don't think it's going to be anything to do with that little transistor or voltage regulator, whatever it is. Haven't actually looked, so I don't know. Yeah, we still get a short there. As you can hear there, we do still get a short on that line. Okay, so it's nothing to do with that. So I'm going to get some leaded solder on there and drop that back on. And at the same time, I'm going to remove the Southbridge from the board and see if that short disappears. It probably will. It probably is going to be the Southbridge. 90% of issues with no power on the PlayStation 4 were down to the Southbridge when we had a shorty Southbridge. And the reason for that is because most of the voltage rails are handled by the Southbridge. I'll just replace the solder that's on there at the minute with fresh leaded solder. And then I'm going to drop this back on. So ideally I need to be taking my nozzle off though. So I'll do that first. And then while I'm reflowing the Southbridge so as it can be taken off, I'll also be flowing this chip down. I do have a strong feeling that it's going to be the Southbridge at fault. Okay. So I'm going to be flowing all of this down. I'm going to get some flux and just add that around the Southbridge. Don't want to be damaging any pads under the Southbridge, do we? So we add some flux. And same temperature, 420 degrees Celsius. I'm going to flow that down first. There we go, that's flowed down into place. And there's the Southbridge removed from the customer's board. Let's pop under the microscope a minute. So the reason I will do that without the microscope is because I need to hold the hot air on a straight angle to be able to make sure I'm controlling the hot air enough so as it doesn't go near the APU. Okay, so what I need to do first of all is I'm going to need to replace all of this solder that's here with some fresh leaded solder. And the reason for that is because the solder that's on there at the minute is going to be lead free. And lead free solder has a much higher melting temperature than leaded solder does. So when we try and wick away the pads, so basically when we try and clean them, it's going to come to a point where it's not going to wick away and it's going to damage the pads trying. So we add leaded solder, that's going to mix the leaded solder with the lead free. It's going to lower the melting temperature by changing the mixture, and it's going to basically allow us to wick it away a lot safer than if we was just using lead free. I'm going to add a blob of solder onto the iron, and then I'm just going to run the iron across very gently onto these pads. I'm imagining it's probably going to be close to 400 solder balls which I need to place onto this chip. I'm probably going to say it's going to be a 20 by 20 chip and then a couple missing here and there. It usually is on the PS4 Slim onwards. So from the CXD 90042 GG, it's been a 20 by 20 chip. So that's 20 balls across, 20 balls down. So it's a squared chip, and then basically there's the odd couple of solder balls missing here and there. I think it comes to about 393 balls, which isn't too bad. Seems like a lot, but it's not that much, not when you think about it. When you think about the kind of responsibilities this chip has, not a lot of connections. It's annoying to have to do by hand, but when we can't buy these chips because the manufacturer won't let us, that's unfortunately the only option. So what I'm going to do now, I'm going to get some solder braid and I'm going to clean this away. So I'm going to wick away the solder that's there, bring the pads back to how they would have looked when it came off the factory line, and then we'll take it from there. And then I can take the chip from the donor board and reboard it. I've got some solder braid here. I'm just going to go around in a circle very gently. And yep, there are a few pads missing here and there. So not only do we want to make sure that we don't tear the pads, we also want to make sure that we don't end up damaging the conformal coating too much. And the reason for that is because if we damage the conformal coating, what's going to happen is when we go to place a new chip down, the traces themselves are going to be tinned, and then the solder that's on the balls are going to basically flow across the trace as well, making that specific ball smaller, meaning it wouldn't make enough of a contact. The balls have to be even, or as close to even as possible, to be able to make a contact with every pad. So I've wicked it a little bit. I'm going to clean away the flux, and then I'm going to put some more flux there and wick it once more, make sure that we've got some nice even pads. I'm not worried about the excess flux on the edge, I just want to clean off the area I'm working with. I can clean up fully once I'm done. I'm just trying to clean up this area because it's where I'm working, and it's going to make my life a million times easier than just adding fresh flux and trying to wick it away. So isopropyl alcohol with a cotton swab will do the trick. There we go. And now I'm going to add some more flux. So some fresh flux. When the flux starts to burn, it makes it difficult to use, and it stops the solder from flowing properly. So I'm going to add some fresh flux here, and then I'm going to wick it away once more. I'm going to go with one more pass on the solder wick, and that should get them all nice and flat. They look fairly flat as it is, but it should get them nice and flat. Must remember that once I've finished wicking this, I'm going to need to touch up those two resistors on the side. I did just hit them with the solder wick, I need to make sure that there's enough solder on them. And I'm just going to touch up these two resistors. There we go. Just make sure there's enough solder on them. So I'll heat up the area. When the flux becomes hard and dry, it basically refuses to budge. So I'm just heating it up a little bit before you try and clean it away, which is going to give you a massive help. Otherwise it's going to be very difficult to clean up. While it's warm, see how much easier that is compared to what it was earlier. Alright, so I'm just going to scrub it a couple of times, and then I'm going to scrub it with a toothbrush and some isopropyl alcohol as well, just to get in all the little nooks and crannies and make sure all the flux that's there is cleaned off. I use a toothbrush and you can just pour a little bit there. It's non-conductive, doesn't matter if it's got a little bit of isopropyl alcohol on. The IPA is non-conductive. Okay, just going to dry that off with some warm air. Beautiful. Alright, so that chip there does actually look like some sort of a BIOS chip or something, so I don't think it's going to be related to power management, but I did just want to check it to make sure. Just run my finger across them, see how flat they are. They feel perfectly flat to me. So let's flip the board around and let's see if we've still got a short on this coil. If we have, then we've got to go hunting. What we shouldn't have, I keep calling it a coil. It's an inductor. There we go. No more short. And there we go. Beautiful. Short gone. Excellent. Absolutely beautiful. So that's cleared the short, which means that we should be good to just take another Southbridge and replace it, and hopefully it's going to work. And we might have just fixed the first PS5 with no power, or rather the first PS5 that I've done with no power. I'm presuming someone's going to have come across one at some point. So I'm going to add some flux here. I'm going to do this exactly the same way that I've just done the other one. So this is the donor board, and I'm going to do this exactly the same way as I've just done the other one. I'm going to remove it using hot air at 420 degrees Celsius. So there's the Southbridge removed. Let's hope it didn't kill it by taking it off, because that is a possibility. Okay, so I'll just secure that in there. It's going to keep it nice and steady, and I'll pop it under the scope. So I'll add some flux here, and what I'm going to do is I'm going to do exactly the same as I did with the board. I'm going to add some leaded solder, lower the melting temperature of that solder, and then wick it away so that we've got some nice clean pads, a fresh blank canvas to work with. So I'm imagining that these solder balls here, the ones that are on the original chips, are likely going to be 0.45 millimeters. That's what they are on all of the other Southbridges for the PS4. So I'm assuming they're probably going to be keeping with the same size. Okay, I can see a few oxidized pads here as well. So I'm going to have to try and deal with them. And hopefully it doesn't damage the chip itself while I'm trying to wick away the pads, because that would be devastating. These chips are probably worth £40 to £50 right now. The CXD 90042GG costs around about £15 to £20 off AliExpress. And if you can't get the chips, chances are they're going to be worth more. That's wicked away the majority of it. So I'll just clean up and inspect the pads, and I'm going to need to do something about that oxidation as well. But I'll show you what we can do for that. There is a little trick we can use. And that's in a right weird shape. Quite a few solder balls missing there. That's a nice funky shape. Interesting. Alright, so because there's a few oxidised pads here, we've got several actually. We've got one here, so you can see how grey that looks. We've got one there, and one there. So 4 in total. So let's just try and tackle these. So what I'm going to do is just give it a little bit of a really light. So what I'm going to do is give it a nice gentle scrape with the tip of my knife. Just trying to scrape away some of the oxidation. There we go. So we'll just expose a little bit of the pad. And I'm going to do the same for the other ones. The reason we do this is because if these pads are oxidised, then the solder's not going to stick to them. So we want to try and clean it up and then give it a nice fresh pad to be able to solder to. Okay, so there's those pads, not restored but cleaned. Still not quite ready. So ideally now we want to be able to make them look a little bit better. So I'm going to add a little bit of flux. Same as up there. And then I'm going to use a soldering iron and I'm going to add some solder to it. So I'm going to re-tin those pads using solder. Just like that. So put a nice little blob of solder there. And there. And there. And there. So just add some blobs of solder. And then I'm going to take the wick and I'm just going to wick it back off of the chip. And it should leave us with some nice shiny pads. And that is indeed nice and shiny. Let's have a look at this one down here. Or up here rather. There we go. Looking good. Looking good. Beautiful. Alright, so let's just clean up again. And now that pad is singing, I feel pretty, oh so pretty. I feel pretty and witty and gay. Anyway. Anyway. Let's just clean that off fully. Make it look nice. And is that meant to be a pad there? Huh. It's kind of symmetrical with the other ones. Ish. Let's have a look at the original. Okay, so we're meant to have... Yeah, I think it's that way. Yeah, there's meant to be a pad there. Let's hope that pad's not missing. I thought it looked a bit odd. There you are. There you are, Mr. Pad. Oh, I see you. Alright, let's just double check for any more. Alright, I think it's just that one. I'm not seeing any more outlines of pads. Alright, that was kind of difficult to see, so I'm glad I inspected that a little bit closer. Let's do the same with this one, where we add some solder to it. And then just whack it up, and then just wick it away. There we go, so a little bit of solder there. Well, there we go. Beautiful. Now it feels pretty. Awesome. That's looking beautiful. Little bit of a blob there. Let's see if we can get rid of that. So these do need to be as flat as we can get them, because otherwise the solder balls are not going to sit down straight. They're going to sit all wonky and fly all over the place. We don't want that. So we want to try and get this looking as good as possible before we do anything. Alright, I think that's fine. That's good to go, to be honest. I think it's good to go. There's one just in the middle which is a little bit dull, but it's not dull enough to concern me. So what we need to do now is we need to add the tiniest amount of flux. And when I say the tiniest, I mean the tiniest. That's too much. So we need to rub it around, get it all nice and spread out. And then I'm going to wipe my finger away and just keep wiping it down. Just a couple of times. We want literally just enough to allow the solder balls to basically make a contact with the flux and hold it in place, so as we can place the balls manually. Now what we need to do is we need to drop the solder balls on top and then basically position them. So I'll show you how I'm going to do a few, but I'm not going to make you sit there and wait through all of it, because it is going to be a tedious process. It's going to take me around about 20 minutes to do, and it's not going to be fun for you to sit there and watch through. So I'll get this done. I'll show you how I'm going to do it. So here I've got some 0.45mm solder balls. I'm just going to sprinkle them all over there. Doesn't matter if I add too much. Don't mind adding too much. And what I'm going to do is I'm going to grab some tweezers. And I'm actually going to grab a brand new pair, if I can. And what I'm going to be doing, I'm going to zoom in so I can see it properly. And then essentially what I'm going to do is just manually place all of these solder balls onto each pad one by one. And 0.45mm is the perfect size. So 0.45mm is the size which was used on the PS4, which is why I just pretty much went straight for those balls. But essentially what I'm going to be doing is I'm going to be doing this. Just taking one ball and placing it manually onto every pad. Once that's done, I can flow them down and solder the balls to the pad and then solder the chip to the board. So that's literally all I'm going to be doing. Like I said, it's a tedious process. It's not exactly fun. It's not easy. I do surprisingly enjoy it. It's kind of like relaxing for me, apart from when the solder balls stick to the tweezers. That just annoys you. I'm probably going to need a different pair of tweezers. But what I'm going to be doing first anyway is going to grab myself a beautiful cup of coffee. Because I'm not sitting here and reballing a chip without a coffee in front of me. So basically that's what I'm going to be doing. Like I said, it's going to be tedious. It's not going to be easy. But once I get my coffee, I'll fast forward through and get that done. Alright, so with the balls in place, what I'm going to do is I'm going to take it nice and slow, and the reason for that is because I'm still a little bit concerned that the flux might end up rolling over onto the chip. So I'm going to take it nice and slow and monitor it carefully and just make sure that it's not going to end up flowing down onto the chip. If it does, then I'll take the chip off the jig and I'll put it onto the blue mat and do it that way instead. So I'm going to knock my airflow down to 1%, which is my normal airflow anyway, but I'm just going to monitor it really carefully as I'm doing it. So my airflow is at 1% and my hot air is at 420. And I'll know fairly quickly whether it's going to cause an issue or not. But I've got the hot air pretty far away, around about 6 inches away from the chip, and that's going to melt the flux enough to give me an idea of what's going to happen. You can see a couple of these balls are starting to move slightly. Don't worry about that. You just want to keep a nice close eye on it and make sure they don't move off the pad. If they move off the pad, or if two balls move too close to each other, then you could end up with merged balls. It's not so bad on the edge of the chip, but if you get that in the middle of the chip and you've got to sit there and try and wick that away, you've got no chance without wicking away a hell of a lot more balls in the process. It's a nightmare. You don't want merging around the middle of the chip. Around the edge, not so bad. Just wick away the edge and move on. But in the middle, it's a nightmare. You end up having to reball probably about 50 or 60 balls a lot of the time just to be able to get to it. I've still got the hot air fairly far away. It does look like the flux on the edge isn't going to cause too much of an issue. So I can move in a little bit closer. They are starting to knock themselves into place now. I don't think we're going to have any issues now. So you can see just how slow I'm taking it. But you can also see just how easy it is to mess up. All I'm doing is slightly moving a couple of millimeters and it's moving some of the balls to a point where it looks like they're going to move off the pad, but they shouldn't move now. That should all be nice and secure now. I'm going to come from the other side. I want those pads in that bottom corner to move. I don't think they're going to though. Alright, I think that's fairly safe to call all of those balls secure. So I'm going to let all of those balls cool down. You'll see that they're going to look a little bit nasty. They're going to look like they're cracked and things like that. Don't worry, it's because we've got no flux on at the minute. And this is the importance of flux. There is a ball in that top left corner which I don't think is quite going to be secure. So I'm going to just try and flow that down. There we go, I can see it moving. Come on. Come on. I think it's secure enough. It's not budging. Let's just let them settle again. So it looks bad now, but once I add some flux in a second, it's going to look fine. I'll increase the airflow to 5% and it should take care of it. So I should be able to add flux without worrying about it causing any to float away. Increase the airflow to 5%. And I'll just let that flux spread out a little bit. And then I can see where I need to add some more flux. There we go. Let's flow that down. This is where it could go wrong, because they're going to jump into place in a minute. So it could go wrong here, which is why we're still taking it fairly slow. Okay, here we go. Now that top corner, what's that looking like? That's looking good. Okay, I've got a ball which has managed to find its way on. Luckily I noticed that soon enough. Didn't cause any issue. I don't think any more managed to creep on. Or at least I think it crept on. Alright, I'll increase to 20%. And that's going to be the final flow. Let's wait for them all to go shiny. Okay. That's good. That went absolutely perfect. Okay, with that done, I can figure out where the chip's going to go. Or which orientation rather. So if you can't quite work it out, what you can do is you can get a little bit of isopropyl alcohol and just rub it on the top of the chip. Just clean up the edges so I can see where the indicator is for pin number 1. We should be able to figure it out. And if not, we could always look at some images online. There's going to be some images somewhere online of this. But we should be able to figure it out with just a chip alone. And there we go, we can see the dot just there in the corner, top left corner. And we've got an arrow on the board. So the arrow on the board indicates where pin number 1 is going to go. So we've got an arrow just here. And that's going to line up with this dot here. So what I want to do now is I want to get this in the right place. So the way I'll do that is to get it roughly in line. So if you look at this here while it's out of line, if I press down on the chip and wiggle it, it's going to move around. But if I've got it in the right place, like that, and then press down and wiggle, it's not going to move, no matter how much I wiggle it. So as long as I put even pressure on it and give it a wiggle, it'll tell me that it's in the right place. So now I'll just press down on the chip with something else, because my finger's going to be stuck to it. And then just release. And that's in the right place now, which means that when we flow this down, it should be perfect. The keyword there, of course, is should. So I'm going to stick at 20% airflow with 420 degrees Celsius. And I'm going to flow this down. So I'm not adding flux yet. There's flux on the bottom of the chip. But not only that, I don't want it to end up floating around all over the place. And if there's too much flux, it's going to float around. So I'll flow it down once until it's roughly locked in place. And then I'll add some flux and then flow it down properly. Okay. So that's going to be roughly locked in. And now I can add some flux. Try not to knock your board when you're doing it. Add flux around the edge and flow it down. Okay, and what we're going to see in a minute is it's going to look like the chip has dropped. So basically, you're going to see it in a minute, the chip is going to basically push the flux from underneath, and that's going to tell me that it's sitting down. And move the air around. Waiting for that flux to start bubbling. Should be any second now. Flux is starting to move. Should be just about getting ready to sit flat. And there we go. Do you see that flux get sucked in? So now I'm going to increase to 40% airflow and I'm going to flow it down once more. This time I'm going to get ready with a pair of tweezers, and then once I feel like it's flowed down, I'm going to give the chip a nudge. There we go. Surface tension pulled that back in. That chip is soldered properly. And there we go. Nice and clean. Nice and clean. Well, clean enough. Alright, so the final thing I want to do is I want to test that inductor again. Just see if that short's come back. It shouldn't have done, but we're going to make sure. So meter in continuity mode again. We've got a ground point just here. And there we go, no beep. Perfect. We're now no longer shorted. If I've done everything right, this board should work. So question number one, what kind of voltage do we get on that resistor that was reading at 2.8 volts? If I can ever get it to make contact, we're getting 3.3. Other resistor, 3.3. We have something different. Is it going to work? We get a beep. We get a single beep. Oh no. Oh. I had a single beep. Oh no. No, 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 no. Do we get voltage on that coil now? Oh, inductor. 1.1 volts. And then off. Oh. 1.1 volts. So that must be an APU line. And then it drops. And then I can press it again. Interesting. Oops, sorry about the wobbling there. That's actually quite strange. If I probe that. Yeah, so I'll press that. It is wanting to turn on. it's not quite getting there. So when I press the button, as soon as I press that button, we get 1.1 volts activated there for the APU, and then it won't turn on. I'm assuming that's for the APU because the APU is the only thing I can think of that takes 1.1 volts. Right, ladies and gents, it's the next day. I've been doing a little bit of research on the Southbridge for the PS5, and it turns out that this might be married. It might be tied to the board. I can't know for sure. I am trying to do a little bit more research. I'm trying to figure this out. But from what I've read, from what I've been told, from what other people have said to me on Discord and things like that, apparently this chip holds the Southbridge for the input and output devices. It holds the Syscon, and it holds the Renesas chip, or something to do with Renesas. That's a big problem, because that means that if these are indeed married, then these chips are not replaceable, and this particular issue is not fixable. And that's super annoying, because the Southbridge on the PlayStation 4 was a major cause of no power. Major cause of no power. It handles voltage rails, so it handles 1.1 volts, it handles 3.3 volts, 1.8 volts. We're screwed if these chips can't be replaced, and it's really, really annoying. So I've reballed the original, so that's the original chip. Apologies about the dogs. So there's a dog barking. Apologies for that. So there's the original chip. I'm going to put that back on. It's 99% chance going to have the same issue, where that particular inductor is going to be shorted out. But if these are married, then I have to put the original back on no matter what. And it means that we're never going to be able to buy these chips because they're going to be console specific. Okay, and time to check this inductor again, but I pretty much guarantee it's going to have the original short, and this console is not going to work, which is super, super annoying. So let's pop the black probe on this one. Oh. Ah, hold on. Original short gone. Wow. How is the original short gone? That was an issue with the chip. How is the original short gone? Unless something's contaminated underneath the chip and it's caused the short, and it's caused that pad to short out. Don't make a lot of sense to me. Alright, well if it works I'll sort out the liquid metal, but if not I'm just going to ignore it and put it back together. Let's find out. I'm skeptical at best. Skeptical at best. Let's see if it turns on. I don't understand why that original short is gone. This bench is a right mess as well. No. Okay, so the original short has disappeared, but it's not fixed it. It's not fixed the original problem. We still have... Oh. Okay, that did make a beep. Okay, so we still have a power issue, but the original short disappeared. That don't make a lot of sense, really. Right, so unfortunately, that is going to be that. It looks like this is going to be unfixable, at least for me, for now. It appears as though the Southbridge chip is married to the board, and if that's the case, then it's unfixable without replacing the APU along with many other components. So it's just not viable to fix in that case, and unfortunately, that's just the way it goes sometimes. But that's going to be it for this video. Thank you very much for watching. If you do have any comments or questions, leave them down in this comment section down below. I will always do my best to answer, and I really enjoy reading comments. And if you do have any helpful information on this, then I would really appreciate if you let me know. If you want to organise your own repair, you can do so by using the website address in the video description. You can get the price list, you can book in a repair, or you can contact me through the website to get a custom quote. And if you enjoy this type of content and you want to see more, then be sure to hit the subscribe button and turn on the bell notifications so that you're notified whenever I release a video. If you want to support the channel, you can become a Patreon supporter using the link in the video description. You can become a channel sponsor using the join button down below the video. Or, as I said earlier, you can head over to Twitch and you can become a Prime subscriber for absolutely free, and that helps out the channel as well. But that's going to be for this video. Thank you very much for watching, and until next time, I'll see you later. Bye for now.